So today we're going to take a look at both creating nets and patterns. Nets and patterns are different ways to actually create a three-dimensional object and make it in the real world. And so with a net, what we end up doing with a net diagram is that we take a two-dimensional representation of a 3D figure and we break that 3D figure down into its two-dimensional components. Okay, and so if you were to unfold the 3D figure, we see what it would look like. And you would have looked at stuff like this quite often, probably when you did grade 9 geometry and so forth, when you had to kind of unpack what a three-dimensional cylinder or a rectangular-based prism would be, or what a square-based pyramid would look like if you were to unfold it and so forth. Okay. And so when you unfold a three-dimensional object, the original figure becomes a flat shape where all the edges meet to keep the net as one single piece. Okay, so all three pieces meet together as a single piece. So one example of a net arises from unfolding a soup can. So if you were to flip up the two circular tops and then cut down the side and flatten it out, it would look very similar to this piece here. Oh, let me go back. It would look very similar to this piece right here, where you'd have the top of the soup can, the bottom of the soup can, and this here would represent the side of the soup can. Okay? So if you were to take a look at this net in the middle, given the following net to the right here, think of what it would form if it was folded up into a three-dimensional figure. So here we've got a square on the bottom, and then the square is surrounded by four different triangles. Okay, and so this could look, multiple different ways. One way that you could look at this is if you had, for example, a square bottom, and then if you were to fold all four of these triangles inward toward a central point, like there, okay, you could actually join those pieces together. Okay. And so it might look something like that. In other words, it will end up being a square-based pyramid. Okay. So it says here that we should determine another example of a net, name the figure, and then draw out the corresponding net in the space below. So if I was to take a cereal box, for example. So let's do quick isometric drawing of a cereal box. Okay, so here I've got a three-dimensional cereal box. If I was to break this up into multiple pieces, what I would end up with is if I were to unfold this cereal box, okay, it has a top piece that is rectangular. Okay, it has a large middle piece, and I will draw the large middle piece. So this here is my middle piece. So I will draw a large middle piece. It has a right side piece, so I'll draw the right side piece. If it has a right side piece, it also has to have a corresponding left side piece as well. Okay. It also has to have another, if it has a top piece, then it also has to have a bottom piece. Okay. And then if I have a middle side that's on the front, I also have to have a backside piece out on the back. Okay. And so if I were to unfold that diagram, it would look something similar to what I've attempted to draw here on the right-hand side. So what we see is we've got a front middle, we've got a back middle. We've got a top side, we've got a bottom side, we've got a right-hand side, and a left-hand side. And if you fold all of those pieces together, it will get you back to the original three-dimensional drawing that you have. And that's the beauty of a net diagram. So those of you who are responsible for recycling in your house, if you ever break down cereal boxes or other boxes, chances are you've encountered net diagrams in a manner multiple times. So you can break down basically any box into a net diagram because that's how they're designed, and to flatten it out so that it's easier to recycle.